right, everyone, get ready because today we are taking a deep dive into consciousness.
Ooh, that's a big one.
It is. It is one of the biggest mysteries out there, really.
Yeah, for sure. And probably one that we could spend, years and years talking about and still only scratch the surface.
Exactly. But that's what we're here for, to kind of guide you through that jungle of ideas and highlight some of the most fascinating and important points.
Right.
And for this deep dive, we've got a couple of really great sources that we're drawing from. One is Robert Lawrence Kuhn's paper called A Landscape of Consciousness Theories, which is kind of it lays out a spectrum of different perspectives on consciousness. And then the other is some really cutting-edge research on this AI called Brain LM.
Oh, wow.
Which is it's really fascinating stuff. It's been trained on thousands of hours of fMRI data, and it can actually predict mental states from a brain scan.
That's incredible.
I know, it's mind-blowing. We're talking anxiety, PTSD, even the severity of depression. I know, it's incredible stuff. So those are some of the things we're going to be exploring today. Big questions like, could a computer be conscious? Is consciousness more than just the brain? Could AI help us finally understand what consciousness is?
Right.
All right, so let's start with Kuhn's Landscape of Consciousness Theories, because this gives us a really good overview of all the different perspectives out there.
Yeah.
So what's the first stop on our consciousness tour?
Well, I think we have to start with materialism.
Okay.
And this is probably the most common view in science today. And basically, it's the idea that consciousness is a product of physical processes in the brain and nothing more.
Okay, so it's basically saying our brains are like complex machines, and consciousness is just one of the things they produce.
Right, like digestion is a product of the digestive system. It's all about the physical nuts and bolts.
Right.
And one of the key thinkers in materialism is John Searle, who argues that consciousness is simply a system feature of a complex brain. So just like digestion is a feature of a well-functioning gut, nothing mystical or supernatural about it.
Right, right. But then that kind of makes me wonder about the experience of consciousness.
Yeah.
You know, that feeling of actually seeing red or tasting chocolate.
Right.
Can materialism really account for those kinds of subjective experiences?
That's the million-dollar question, yeah. And this is where we get into this concept of qualia, which is the subjective feeling of what it's like to have an experience. And it's a huge point of debate, even within materialism.
Yeah, I mean, because some materialists would say, like David Papineau, he calls it a pseudo-problem.
Right.
This whole qualia problem.
Right, exactly. He basically says there is no hard problem of consciousness. It's all just brain activity, and it's no surprise that that activity feels like something from the inside.
Okay, so he's saying that's just kind of our perspective on it. But it's nothing more than those brain processes.
Exactly.
Okay. But then other materialists take kind of a different approach, like Owen Flanagan.
Right.
And he emphasizes kind of the evolutionary role of the brain.
Yeah, he basically argues that, the brain evolved for survival, and our introspective abilities might not be as reliable as we think. Maybe our self-awareness is just kind of a byproduct of the brain trying to keep us alive.
Right. It's not necessarily giving us a perfect window into what's actually going on.
Yeah, exactly.
Interesting. So even within materialism, there's a lot of different perspectives.
Yeah, a lot of debate.
Okay. Well, what if consciousness isn't just about the physical stuff of the brain?
Yeah.
What if it's more about how the brain processes information?
Yeah, this is where we start to get into information processing theories of consciousness,
right?
Which propose that, consciousness arises from the way our brains handle information, kind of like a supercomputer running a complex software program.
Okay, so we're moving on from the brain as a machine to the brain as like an information processor.
Precisely.
Okay, and one of the most popular theories here is global workspace theory.
Yes.
So what is that all about?
So imagine the brain as a vast network of specialized processors, all working on different tasks. You've got areas for vision, hearing, language, memory, and so on.
Right, so different parts of the brain are kind of like different departments in a company.
And each one has its own expertise. But then consciousness is kind of like a spotlight that shines on certain information, making it globally available to the whole system.
Okay.
So only the information in the spotlight is what we're consciously aware of at any given time.
Right. So that would explain why we have such limited focus.
Exactly. We can't be aware of everything at once. We only have so much processing power to dedicate to conscious thought.
Right. That makes me think about like all those times I've zoned out in a meeting or driven home on autopilot. And I'm like, Where am I? What am I doing?
Yeah, exactly. Your consciousness spotlight must have been somewhere else entirely.
Exactly. Okay, so we've got this spotlight shining on information in the brain,
Yeah.
but how does the brain decide what to shine the spotlight on? What determines what we become consciously aware of?
That's the big question.
Yeah. And it's something researchers are still trying to figure out. But some suggest that emotions play a key role.
Yeah.
Prioritizing information that has survival value.
Right.
Others emphasize the role of goals and intentions.
Right.
It's likely a complex interplay of factors.
So that's global workspace theory, which is one way of looking at consciousness through this lens of information processing.
Right.
But then there's also integrated information theory.
Yes. Integrated information theory, or IIT.
IIT. Okay, so what does that one say?
So this one takes a slightly different approach.
Oh.
It suggests that consciousness is directly related to the amount of interconnected information in a system.
Okay.
So the more complex the web of information, the higher the level of consciousness.
Okay, so something simple like a light switch
Right.
would have very low consciousness because it's either on or off.
Exactly.
But something like the human brain with billions of interconnected neurons has a much higher level of consciousness.
Exactly. And here's where it gets really interesting.
IIT suggests that any system, even a computer, could potentially be conscious if it achieves a high enough level of integrated information.
Whoa. Okay, so hold on. So you're saying if we build a computer that's complex enough,
Right.
it could actually become conscious.
It's a possibility.
Okay, so this is opening up this can of worms about conscious AI.
Exactly. And it challenges our assumptions about what consciousness is and whether it's something uniquely human.
Yeah.
Or maybe it's a more fundamental property of the universe,
Yeah.
emerging wherever we find complexity in information.
Okay, wow. This is getting deep.
It is.
We've gone from the brain as a machine to the brain as an information processor.
Right.
And now we're venturing into the possibility of conscious computers.
That's right.
All right, so where do we go from here?
Well, there's another stop on our tour.
Okay.
And this one emphasizes the importance of our physical bodies and their interactions with the world. We call these embodied and inactive theories of consciousness.
Okay, so it's not just what's going on in our heads, but it's about our bodies and how we move through the world.
Exactly. It's about the interaction between the brain, the body, and the environment,
Okay.
all working together.
Okay.
And I love this quote by the philosopher Alvin Noe, who says, "We spend all our lives not as free-floating brains. We're embodied. We're environmentally embedded. We're socially nurtured."
Wow, that's a powerful statement.
It is.
It's like you can't separate the brain from the body from the environment.
Exactly.
It's all one big interconnected system.
That's right.
Wow.
Yeah.
So this kind of raises the question then.
Yeah.
Could a disembodied brain, even if you kept it alive in a vat,
Right.
could it truly be conscious?
Yeah. It's a good question, right?
Yeah.
If consciousness depends on this interplay with the world,
Yeah.
then a brain that's cut off from its body and its senses might experience a very different kind of consciousness, if any at all.
That's a trip.
Yeah.
Okay, so we've covered materialist views.
Right.
We've covered information processing theories.
Yeah.
And now this idea that consciousness is all about embodiment and our interactions with the world.
Exactly.
There's so much to consider.
And we've only just scratched the surface.
I know there's so much more to talk about. We still have to venture into those mind-bending realms of quantum theories of consciousness
We do.
and explore this incredible potential of brain LM
Yes.
to actually illuminate the workings of the brain. Let's dive into those quantum realms and see where they lead us.
Okay, so get ready, because now we are venturing into a realm where things get really, really strange. The world of quantum theories of consciousness.
Quantum theories. I always thought that stuff was more about the subatomic world, not our thoughts and feelings.
Right, that's the common perception. But some scientists believe that these really weird quantum phenomena that happen at the subatomic level might actually be essential for consciousness.
So we're not just talking about neurons firing, but about something even weirder happening at the quantum level inside those neurons.
Exactly. And researchers like Roger Penrose and Stuart Hameroff have been exploring this idea for a while. They suggest that these tiny structures within neurons, called microtubules, might be the key.
Microtubules. Okay. I vaguely remember those from biology class. They're like little scaffolding inside cells, right?
Yes, they provide structural support and help transport things around the cell. But Penrose and Hameroff believe they might also be involved in something much more profound, orchestrating the quantum dance of consciousness.
Okay. I'm officially intrigued. Tell me more. How can these tiny tubes be involved in something as grand as consciousness? I mean, it seems like a pretty big leap.
It's definitely a radical idea, but the basic premise is that quantum mechanics, which governs the behavior of particles at the subatomic level, is full of these strange phenomena that could be relevant to consciousness.
Right, like things like superposition, where a particle can be in multiple states at once,
Exactly.
and entanglement, where two particles become mysteriously linked even across vast distances. Spooky action at a distance, as Einstein called it.
Exactly. And these effects, these quantum effects, they're not just theoretical curiosities. I mean, they're being harnessed in cutting-edge technologies like quantum computers.
So how does this all connect to our brains and consciousness?
Well, Penrose and Hameroff propose that microtubules, because of their unique structure and organization, could create these conditions where quantum effects become amplified and sustained.
Hold on. So you're saying these tiny tubes inside our neurons could be like little quantum computers generating consciousness?
It's a very bold proposition, and it's still very much a fringe theory, but, it's not entirely without merit. There's been some research that suggests that anesthetic drugs, which disrupt consciousness, might actually work by interfering with quantum processes in microtubules.
Wow, that's pretty wild. So if anesthetics are messing with quantum stuff in the brain, that does suggest it might be important for consciousness, right?
It's an intriguing clue, for sure. But obviously, much more research is needed to confirm or refute these quantum theories of consciousness.
Right. Okay. So quantum theories are kind of exploring those subatomic underpinnings of consciousness. But then we also have this incredible AI, brain LM, that we talked about earlier.
Yes.
That's helping us understand the brain from a completely different angle.
Absolutely. BrainLM has been trained on these massive data sets of fMRI scans. So it's soaking up all this information about how the brain works in different mental states. It's like it's learning to read the language of the brain.
And we're talking about a truly massive amount of data, right?
We are.
I read that brain LM was trained on the equivalent of watching The Lord of the Rings over 465 times in fMRI data.
That's right.
That's mind-boggling.
It is. And what's remarkable is that BrainLM can now take a new fMRI scan from someone it's never seen before and make predictions about their mental state with pretty stunning accuracy.
Wait, it can do all that just from looking at a brain scan? That's incredible.
It is.
How does it even work? Is it like mind reading?
Not mind reading in the traditional sense, but it's definitely tapping into something profound. So remember, fMRI measures brain activity by detecting changes in blood flow. So when a part of the brain is active, it needs more blood and oxygen, and fMRI picks up on those subtle shifts.
Right, so it's like we're seeing the brain light up in different areas depending on what someone is thinking or feeling.
Exactly. And BrainLM has basically learned to recognize those patterns of activity, those neural signatures that correspond to different mental states. So it's like it's cracked the code of the brain.
Okay, so it's not that brain LM is thinking like a human, but that it's become incredibly good at decoding the patterns of brain activity that reflect our thoughts and emotions.
Precisely. And here's where it gets even more fascinating. BrainLM uses a technique called self-attention, which allows it to focus on the most informative parts of the fMRI data, just like we selectively focus our attention on certain aspects of our environment.
So brain LM isn't just passively absorbing the data, it's actively choosing what to pay attention to, what's most relevant for making these accurate predictions. That's amazing.
It is. And by analyzing these attention maps, which show us where BrainLM is focusing, researchers are gaining new insights into how different mental states are represented in the brain. It's like we're getting a glimpse into the inner workings of the mind.
This is groundbreaking stuff. What are some of the most exciting implications of this brain LM research?
Well, for one, it provides further support for the idea that mental states have a physical basis, right, detectable through brain activity. And this has huge implications for the diagnosis and treatment of mental health conditions.
Imagine a future where we can use AI to not only diagnose conditions like anxiety and depression more accurately, but also to tailor treatments to an individual's specific brain activity patterns. I mean, that would be revolutionary.
It would completely change the landscape of mental health care. BrainLM is also helping us understand how different parts of the brain work together as a system. It's able to identify these functional brain networks, clusters of brain regions that work together to perform specific tasks without any prior knowledge of what those networks are.
So it's like brain LM is creating a map of the brain But it's doing it without a guidebook. It's figuring out the connections and relationships on its own simply by analyzing the patterns of brain activity.
Exactly. And that's a huge step forward in understanding how the brain works as a whole, how these different regions communicate and collaborate to produce our thoughts, emotions, and behaviors.
This is incredible. But the question that keeps popping into my head is, with all this amazing progress in neuroscience and AI, are we getting any closer to understanding what consciousness is? I mean, is BrainLM giving us any clues about that ultimate mystery?
It's the question everyone wants answered, right? And while BrainLM doesn't provide a definitive answer, it does offer some tantalizing hints. The fact that an AI can learn to predict and understand these really complex mental states, that it can decode the language of the brain, it suggests that maybe consciousness is more about information processing than we previously thought.
So instead of consciousness being this mysterious, ethereal thing, it's actually rooted in the physical structure and activity of the brain, in the way information flows and interacts within that incredibly complex network.
That's one interpretation, and it's a very compelling one, right?
Yeah.
BrainLM is really pushing us to reconsider the relationship between the mind and the material world.
Yeah, it's definitely mind expanding. We've gone from the brain as a machine to the brain as an information processor, from quantum theories to AI that can decode the language of the brain. It seems like our understanding of consciousness is evolving really rapidly.
Absolutely. And as we continue this exploration, we need to be prepared for even more surprises and challenges along the way. There's another fascinating theory that we haven't even touched on yet called the Free-Energy Principle.
The Free-Energy Principle. Okay, I've never heard of that one.
It suggests that the brain's primary function is actually to minimize surprise.
Minimize surprise. That sounds almost counterintuitive. I mean, don't we need surprise to learn and grow? Don't we crave novelty and unexpected experiences?
We do. But the Free-Energy Principle proposes that the brain is constantly striving to minimize surprise in a very specific way by creating a model of the world that predicts and anticipates incoming sensory information.
So instead of being surprised by everything, our brains are constantly trying to stay one step ahead, predicting what's going to happen next.
Exactly. And any mismatch between our predictions and reality, that creates what's called a prediction error, which the brain then tries to minimize by either updating its model of the world or by acting on the world to make it conform to its predictions.
So it's like our brains are running these simulations of the world constantly, refining them based on new information and using them to guide our actions and perceptions.
That's a great way to put it. And some researchers believe that this process of prediction, error correction, and model updating might actually be the key to understanding how consciousness emerges.
Wow, that's a big leap. How does minimizing surprise connect to something as subjective and elusive as consciousness?
That's where things get really, really interesting. And that's actually where we'll pick up in the final part of our deep dive. We'll explore how the Free-Energy Principle might explain not only how our brains work, but also how we experience the world, how we feel, think, and make sense of reality itself.
Right, so last time we were talking about this mind-bending idea, the Free-Energy Principle, which suggests that our brains are constantly trying to minimize surprise by building these models of the world. And I'm still trying to wrap my head around how that relates to consciousness.
Yeah, it's a complex idea, but I think if you remember how we talked about the brain creating this model of the world, it's not just a model of the external world.
Right.
It also includes our own bodies, our actions, and even our internal states.
So it's not just a model of like the world out there, but also me in the world.
Exactly.
Including my feelings and sensations, and even that sense of self that we were talking about earlier.
Exactly. It's like our brains are creating this integrated simulation that encompasses both our internal and external realities. And some researchers think that consciousness might actually emerge from this process of the brain modeling itself. Of incorporating its own activity into its predictions.
So it's not just about predicting what's going to happen next in the external world, but also like how I'm going to feel and react to those events.
Right.
It's like my brain is running a simulation of me experiencing the world.
That's a great way to put it.
Wow.
And the more accurate and detailed that simulation becomes, the richer and more nuanced our conscious experience might be. It's like our brains are striving to create the most immersive, virtual reality experience possible.
Yeah.
And that experience is what we call consciousness.
That's a wild thought.
It is.
If our consciousness is essentially a simulation, does that mean it's not real?
Well, that's a question that has puzzled philosophers for, centuries.
Right.
But what if the line between real and simulated isn't as clear as we think?
Okay.
What if our brains are creating a model of reality that's just as real as reality itself,
Hmm.
just experienced from a different point of view?
So it's not that our conscious experience is fake,
Right.
but rather that it's like a unique way of accessing and interacting with reality,
Exactly.
shaped by our brain's, predictive models.
Precisely. It's like we're experiencing the world through a filter.
Right.
But that filter is an essential part of what makes us human.
Yeah.
It's how we make sense of things and how we navigate our lives.
This is blowing my mind. So the free energy principle isn't just a theory about how the brain works.
Right.
It's like a potential framework for understanding consciousness itself.
It's a very promising avenue of research, and what's even more intriguing is that some researchers believe that the free energy principle might not be limited to just the brain.
Okay.
They suggest it could apply to any self-organizing system, from single cells to entire societies.
Wait, hold on. Societies can minimize surprise, too.
Well, think about it this way. Societies develop these systems and structures to anticipate and manage uncertainty.
Okay.
We have laws, customs, institutions, cultural norms. These are all ways of creating order, of minimizing surprise at a societal level.
So it's like societies are kind of collectively trying to build a model of the world that makes sense.
Exactly.
A model that allows them to function and thrive.
Exactly. And when those models break down, when unexpected events happen,
Right.
societies adapt and evolve, creating new systems and structures to manage this new reality.
It's fascinating to think about the free energy principle, operating at all these different levels of complexity,
I know, it's pretty amazing.
from the individual brain to entire societies.
It really is.
It suggests that this drive to minimize surprise, to predict and control our environment, it might be like this fundamental force shaping life itself.
It's a very profound idea.
And it makes me think about artificial intelligence.
Right.
Because if the free energy principle is kind of a key to understanding intelligence, then could it be a blueprint for designing AI systems that are more adaptable, more robust, and maybe even capable of something like consciousness?
It's certainly a possibility.
But then that raises all sorts of ethical questions, right?
Absolutely. I mean, the ethical considerations of AI development are paramount. But the free energy principle, with its emphasis on minimizing surprise and maintaining order, might actually offer some guidance for creating ethical AI.
Yeah.
If we can design AI systems that are driven to understand and predict the world rather than control or exploit it, then perhaps we can foster a future where humans and AI can coexist harmoniously.
It's a hopeful thought, but it really highlights the importance of approaching AI development thoughtfully and ethically,
Absolutely.
and with a deep understanding of these fundamental principles that govern both biological and artificial intelligence.
I completely agree.
Well, I think that's a great place to wrap up our deep dive into consciousness. We've explored a wide range of theories, from the material to the quantum, from the individual to the societal, and each one has shed light on different facets of this really enigmatic phenomenon.
Yeah, consciousness is not a simple puzzle to solve, is it?
No, it's not. It's multifaceted, it's mysterious, it's something that continues to challenge us, to spark our curiosity, and to push us to explore the depths of our own minds and the nature of reality itself.
I think as we continue to grapple with this mystery of consciousness, the most important thing is to remain curious, open-minded, and willing to embrace the unknown.
Well said. We've covered a lot of ground today, but we've only just scratched the surface. There's always more to explore, more to learn, and more to ponder about this fascinating world of consciousness. Thanks for joining us on this deep dive, and we'll see you next time.